it's an interesting demonstration. I'm going to ask Alan, if you would, to hand these cards out while I'm speaking. Those cards have the URL of the website, the main website I'm going to be demonstrating. So, my name is Kevin Hussey. I have a group at JPL entitled Visualization, Technology, Applications, and Development. It's a small group, and our job is to use whatever means, whatever technological means necessary to help the general public and scientists better understand engineering and science data. And we've come across video game engine technology. And I'm hiring game engineers to do some very interesting things, and I want to show you those. Now I'm going to sit down so that I can properly run the computer. All right? And then I'm also going to turn off the lights. And you'll see why, because I do a lot of things out in space. It's dark. Okay, I'm going to start with the application that got this going. It's called Eyes on the Earth 3D. I'm opening up Firefox. I'm going to an application. This isn't the one that's on the card, but I want to show it because it gives you an idea of, of where we're headed with this. Now, that's the wrong version of Eyes on the Earth. This is the new version that we're just working on a release. So I need to set this mic down. Can you hold this for a second, Marco? That's good. All right, so Eyes on the Earth. The idea here is that we had a game engine and we loaded in the data for the NASA's Earth observing satellites. You see them going here. This is I'm clicking and dragging my mouse around on the globe to look at this. And you see the satellites traveling about, but they're not traveling in a willy-nilly fashion. In fact, they're linked to this clock and calendar here. So if I click this button that says real time, you now have the actual location of these satellites as we speak. So if I double click on Calypso, I'm now go down to a 3D model. This isn't a great model, but right now, Calypso looks like it's over Alaska. Its exact location can be found clicking ground track, looking down, there's its nadir point. So you get this idea that we have a 3D environment. We did some things for kids just to kind of, I call them my parlor tricks. For example, we can compare this to a scientist to get an idea of how big it is, or a Porsche 911, all right? And this keeps kids interested, but the real strength of this lies in the data. So I'm going to go to the Aqua mission, the AIRS instrument, and I want to show you, here's a list of data maps that we have available. I'm going to say carbon monoxide today, and this data that I just loaded is fresh as of midnight last night. In fact, at 5 minutes after every hour, we download another swath of data. So because we can't cover the whole globe in a day, we have a 3-day average. So this is today and the last 2 days of carbon monoxide for the entire planet. All right? So let me move on to something that's closer to the lunar moon cam idea. So here's GRACE. GRACE is an Earth analog for Grail, and there's 2 of them. They travel about. I want to show you now their data set. Their data set is a gravity anomaly map. Okay, so I'm going to, there's gravity anomaly, and I'm going to select a date. We can actually do animations. I'm going to go to January 2010 and say submit. It's going to load that data set, and then I'm going to, by the way, because it's, visualization, we can turn lights on and off. I can say relief and give you an idea of the gravity anomaly. And again, if I had more time, I'd show you an animation. So we got done with doing this, and our boss said, the Earth's one thing, but how about the whole solar system? So okay, well, let's move on to the whole solar system then. I'm going to close this. Whoops. I'm going to restart Firefox. And I'm going to go to Eyes on the Solar System. Now, this is that card that I gave you. This is online. Right now, I'm running this. And there are choices. There's a really nice little intro where Amy Maisner talks about it. There are tutorials that I highly recommend. There are particular bookmarks that will take you to specific places in time. But I'm going to just say explore the solar system and load a model of our solar system. Now, you got to grasp this. What we've got here, well, let me go full screen. Hang on. It's in a web browser here. I'm going to make the stars brighter so you can see them better. Okay. This is a model of our entire solar system based on J2000 for the years 1950 to 2050. And we give you a virtual camera that you can place anywhere inside or outside our solar system. So if you see something of interest, you want to go out, all right, let's check out Mars real quick. Go to Mars. Here it is. I can look around and say, see if I can, I'm just trying to, oh, is that Phobos there? No, it's Neptune. You find the Phobos, I'll back up a little, oh, there it is. Double click on Phobos, and if you were at Phobos looking at Mars, that's what it would look like right now. That's the proper lighting. The star field is realistic. You could see Voyager 2 if you had that ability. And hey, you want to go check out Voyager 2? You click on it. We take you to Voyager 2. We show you a very high definition model. We can go back and look at the rest of the solar system. So you get the idea. All right, now, this is right now. Let's take a look at, I'm going to go back to a destination of the, let's look at planets and moons. Let's go to the Earth. Now this Earth, it's a little nicer than the one in Eyes on the Earth, and it has a lot more satellites. We're loading a lot of information right now. My point is, I'm going to take you to a time in the future when Grail is going to launch, or when our spice kernels for Grail launch. Remember, we can go into the future, into the past, and it's taking time to download this. It's okay. So I'm going to go to date and time. I'm going to load in, let's see, I'm going to go to, oh, I can just pull the month slide over here to October. I'll just go to, so I'll say October 20th. I'll submit. And now we're loading satellites that are available at that time. I'm going to look for, there's Grail B and Grail A. See them out there? All right. And there's the moon. Now what I'm going to do is I'm just going to run time forward a bit so you can see their interesting dance with the moon. There goes the moon. Here comes the moon. You guys following this? All right, there goes the moon down south. Here they come. They're going to meet up here very soon. I can zoom back if I want to get a little more. And then keep going. Whoop, shoot. Went a little fast. That's okay. So I just double click on the moon. And now check out the path. Now these are solar-centric paths, but I love to do this because it lets people understand what the spacecraft are actually doing here. All right? So that is their path through the solar system, by the way. We can't change it. We don't have the software now, but we can change it to being body-centric. Right now they're solar-centric. And then if you want to check out one of the satellites, you just double-click on Grail, and this is what Grail looks like. It's a decent model of Grail. And then let me go ahead and turn the light on so you can, all sides. It's a very decent model of Grail. We are going to be able to work with Sally Ride Science. In fact, we are, so that you can position your view through any of these 4 moon cams that are here to see what you're going to see at a specific time around the moon. Right? Now, we have a version of this. How much time do I have left?
About 3 minutes.
3 minutes, okay. We have a version of this that runs in an independent game engine that I may get to. But what I want to do before then is I want to just go back to the home position, which is here, just to show you that, again, it's 3D, but I can grab this and I can move out. And I keep going out. So all those stars are addressable. And this year we're adding the 565 exoplanets that have been discovered around their appropriate stars. Thought I'd share that. Now I'm going to, again, I want to encourage you to go try this. I literally could spend 8 hours here and not show you the same thing twice, because it's 100 years of stuff, good stuff, to look at. But I'm going to leave this to show you what we're going to do. I'm going to do an Alt F4. Okay. Oh, I decided I didn't want to go. All right, it's all right. I'll get rid of it. Now I'm going to load up this program called GoView, which is a predecessor. So think of what we're doing for Sally Ride Science for the Grail mission as an amalgamation of eyes on the Earth and eyes on the solar system. Whoa. And that's a new one. There we go. We're making eyes on the moon that will be about the Grail mission. In this case, you see we have the timeline along the bottom. There's lunar orbit insertion. And we can do the same thing. We can go to either one of those satellites. But I want to take us into the mapping cycle. So we're in the middle of mapping cycle 1. And I'm going to go ahead and click on one of the Grail satellites. There it is. This is Grail A, as it says in the top. And let's look out moon cam number 4. So if you were a student, and that would be your field. Let me change that to moon cam 3. This would be your view. Now I'm going to speed time up a bit. So the kids will be able, students will be able to put in a certain time and be able to get a good estimate of what their photo will be like. This is a planning tool for MoonCam. All right, so again, I could spend a long time talking about this. I do want to pause now to ask if there are any questions that I might answer about this. How many minutes do we have left for questions?
We have about 2 minutes left for questions.
Go ahead.
Do you guys have any questions?
Yes.
Yeah, go ahead.
You showed how it showed carbon monoxide. Showed how it showed carbon monoxide.
Yes.
Could you do temperature? Could this be a global change modeling exercise as well?
And as a matter of fact, yes. I'm very quickly going to go back there and show you that, in fact, we have, oh gosh, how can I put this? We have,
Kevin, are you going to be
yes.
around today?
Yes, I'll be around. The answer is yes. We have temperature, ozone, carbon dioxide, carbon monoxide, all of them updated regularly. Not as regularly as carbon monoxide, ozone, and temperature. But as you can see, the potential for this is mind-boggling, and we are receiving, working on receiving the funding to try to amalgamate as many data sets into this platform, because it's very easy to use. It's intuitive. Kids love this. The adults have a little trouble with it, but kids just tear into this thing. Tear into it. Any other questions I can answer?
I have a feeling you're going to get mobbed when you
That's fine.
have a break.